We are going to see now how using the CAMPG generated first order differential equations we used to produce a block diagram. So I corrected that. And so what we need to do is, if we have this bond graph in here, all we need to do is to enter this into the CAMPG software, and then we will generate those files to MATLAB and generate the state space form, and then using the Cauchy form equations which were used to find the state space form, we will draw a block diagram. So in here we have a situation where we are going to go to the CAMPG software here. So this is the drawing part that we have, and I think that's the entire bond graph. So we could use this and just do it on the right hand side. If you do it in the order that it's specified in here, you can keep also the bond numbers. So in here we go to the 0 over here like this, and then you put C number 3 over here like that, and then you have the 1 on this side like here, and this would be number 4, and then I over here, so this is number 5, and R on this side, this will be number 6, and then of course we have a 0 over here, and then we draw this one, and then the C over here where we draw this other one. Okay, then you have a 1 here, and then you click over here, so that's number 9, and then there are element up here which would be for number 10, yes, and then of course we have the source of effort, which would be for number 11. So if we want to, for this one in here, this would be the last one. So in here we can move this a little bit in here and put that AC11 on this side. And so that way we'll put it on this side over here like this. Oops. AC11 like this. Okay, so now if you want to make the bond graph pretty, the CAMPG has tools to move the elements. So like for example this C, we'll move it to make it like that, and this we're going to move it up. So this for moving this one up here, which is just for aesthetics, have nothing to do with any computational consequences at all. Okay, so in going here and we say interface to MATLAB, and then of course the program will come up with the interface to MATLAB that is working right now, and then we will do the bond graph. Using this bond graph model, produce the files, the M files, that are actually the computer model that MATLAB can execute and do things with, can actually do calculations. So there is MATLAB and CAMPG exercise their handshake, and here's what we have. As a result, we have the MATLAB window where things are done, and in here you have this is the there are these 4 files in here. These 2 are used in the time domain. These other 2 are used in the frequency domain. But this one is the one that has the symbolic matrices and has the equations. Let me show you this back in here. See, right here are the equations. Right there, 2, 3, and 4 in this case. And so what you need to do from here is, though our objective is to generate the state, generate the block diagrams, I will take advantage of the fact that we are here and we could directly generate the matrices just by running this program, this file. As you can see here, it generates the A matrix for the system, and then it will generate the B matrix. It doesn't, as it is, does not generate the C and the D matrix because it is let's see, this, because it's not using any output yet. But I think if you want to, in this case, we can go back to our notes in here. For example, if the output were to be the volume flow rate F10 and also the pressure on the tank E8, we could have those outputs in the we could have those outputs E8 and F10. So in this file you can go on and take a look and find it where that is. And so we click on find, and if we type E sub 8 in here, you see the computer is going to direct you to where those equations of this output are. Those were generated by the CAMPG, and so you're going to tell it that this is the output number 1, and that is going to be part of the C and the D matrix on the first row. And on the second one, if you have F10, just for the sake of example, I'll do the same thing, but this is going to become the second output, and it would be row 2 of the C and the D matrix. So we have to do this because CAMPG doesn't, to start with, doesn't know which output you need, but now it does. So if you run it here, look what will happen. If we look at the MATLAB window over here, see, what do we do? We can run this. It's giving us an error of, let's see, line 21. Did I do something strange there? No? Okay. We need to look at we need to run this file again. So what do we need to do this control C here, and then let's run it clean again. I think that what we need to do is to hold on for a second here. Okay, so now if we run it, look what the computer does now. it says we have two inputs, and it has the state variables in here, but also it's telling me that we have two outputs, E8 and F10. That's the A matrix as did before, and that's the B matrix here, but now it has the C as well as the D matrix together. So we have the whole state space form, and that's all we need. This will give you the characteristic polynomial in here in symbolic form. But for now, I am going to go back to the to this file where the equations are, and I am going to basically let's see, all I need are the equations. I don't need anything else, but I could just take it from this file in here. Let's see, copy. Maybe I just will do a just going to concentrate just on the equations. I don't need anything else, just those four right here. And from this one we're gonna build our block diagram. Okay, so what I want to do is I want to put these equations in the I want to put them in the place where I have the notes to build the block diagram. So I am going to take these ones, and then I will put them in the notes over here and say paste. There we go. So from this I am going to build the the equations. It doesn't matter which one you do it first. I like to do it the one that has more terms, but it's totally you could try anywhere. The only reason I like to do that one, the one that has more terms, is because it will show us all the connections that are missing, and as it progresses it completes. So I think I want to make sure I got all the terms of those equations, and that I did not mess up anything in here. Let me just make sure that we're okay with that. Yeah, I think we did, huh? Yeah, okay. Just checking. So let's go back in here. And I would, like I said, it doesn't matter in which order you do it. Just I would pick up the one that has more terms, just to make sure that we have all the ones here. See, I think I like to draw, but with a little thicker pen in here. So yeah, there we go. We'll do this one. The output is, this is going to be d piece of 5. And you see it has 1, 2, and 3 terms. No sources, but you have one. Let's say I'm just going to go and do this and put the 3 terms that coming into the summation point. This is going to be q sub 3 over c sub 3. The second one is going to be minus p sub 5 over I5. And then the other one is going to be c sub 8 over c sub 8. Let's put the second one perhaps on the last part, be a little easier to see. Okay, let's just make this the q sub 8 over c sub 8. So this is the q sub 8 over c sub 8, and this is going to be the minus p sub 5 over I see. This is our 6 over I sub 5, like that. That's this part in here. From here you can see that you could integrate this 1 over s over here, and this will produce p sub 5. Maybe we could just put the scope in here like this. Yeah, and you can see here p sub 5, and here gets multiplied by r6 over I sub 5, and if you join it here, this of course is a minus, and this a plus and a plus. We have drawn this equation here. Now we need to do the others. I mean, this has two terms, all of them have two terms. So really it doesn't matter at all what we do. In this one, missing a q sub 8, and then this is q sub 3. So like I said, you could do either one of those two next. It does not matter at all. So let me try to see if we can get a little bit more of the on the paper here. Yeah, and here we need to go a little farther down. Okay, so let's just draw it, the next one down here. This is the what I was going to do, q sub 3. Yeah, so we will draw here, and this would be d q sub 3. Again, if you integrate this by 1 over s, then you're going to get q sub 3. And then I put the scope in here. We're gonna go over here and make some spacing here, but I should have done it a couple of times only. There we go. So we are doing this. SF1 is one of the things that we need to put in here, and that is an input in here, which would be SF1, and then p sub 5 over I sub 5, the p sub 5 over I sub 5. But you see, we don't have, that comes from here. See, you can see p sub 5. This goes to 1 over I sub 5, and then obviously this joins here. But see, now this one, that is q sub 3 over c sub 2, that could be built here, right here. This was 1 over c sub 2, right? And that joins this. Okay? And then this is taking shape. We need dp sub 10 dt. We could build it just next to it here, so that we don't have to go all the way down. Maybe we'll build it right here. This is going to be, again, this is d p sub 10, and then it has q sub 8, it has E11 like this is E11, and it has a minus sign in here, so you put a minus sign in there. This one in here has a q sub 8 over c sub 8. This one in here, if you integrate just like the other state variables, this would be p sub 10, and then you could put the scope in here. But q sub 8 is one that we don't have yet, because this is coming from here, and then we need that to complete here, so let's just do it here. This is in here, same thing, d q sub 8 dt, and you do an integration 1 over s, and what do you get? You're going to get a q sub 8. Okay, and then p sub 5 over I sub 5, this is going to be p sub 5 over I sub 5 with a positive sign in here, and this second one that is a p sub 10 over I sub 10 with a negative side. Now, how do we complete this? Do you see how we put together the puzzle here? This piece of 10 comes from this one, and this piece of 5 comes from this. So we will do this. See, we'll take this, multiply by 1 over I sub 10, and you have that. This piece of 5 over I sub 5 comes from here. I would do this. Put it 1 over I sub 5, and then you do the connection right here. Yeah? And finally, this q sub 8 over c sub 8 comes from this one, see? This q sub 8, if you multiply by 1 over c sub 8, and then you connect it here, we finish that one. We only need this last one. It's from q sub 8. So how could we do this? We just need to find a nice way to bring that signal over here. Let's try to see if we can draw it over here. 1 over c sub 8, and that is going to join this right there. And that completes the block diagram for all 4 equations. And when you look in the picture like this, it looks complex in the sense that it has cross lines, and it has, I mean, if you were to look at this first, you would say, oh, what is that? I couldn't understand that. But if you follow the equations the way I did, it would actually make sense. And of course, I am not drawing it pretty. Some of my lines are a little crooked, but if we were to do it pretty in a nice way with the straight lines, it would be much nicer. But this has all the, this is the way you build a block diagram for SIMULINK using the state space form and using the equations that CAMPG produced symbolically for the state space form, which are called the Cauchy form, which you see them on the right hand side over here. I have used these equations to build my block diagram. You could build this sequentially, you know, one after the other in the vertical way, or you could do it in a horizontal way, depending on how you want to lay them on paper, and finding a way that is less confusing for you. Now, there is one way that we can eliminate a lot of these crossover lines, and it uses some of the storage blocks in SIMULINK, but that is something that we will see it in another lecture.